Hello, Carrie Roberts here, and today we're looking at obtaining persistent code execution using Microsoft Office add-in features. So add-ins are extensions you can create to extend the functionality of Office applications like Word, Excel, and PowerPoint. We'll start off by looking at the MITRE ATT&CK framework, which breaks out tactics and techniques known to be used by attackers in the wild against organizations across the world into categories by tactic and techniques. So here we're looking at T1137 Office Application Startup. It can be used for persistent code execution, and this particular technique is broken up into 6 different sub-techniques. If we do the down arrow here, we can see that persistence can be obtained, or this tactic can be used using Office templates, which we're not looking at today. There's a registry key for Office that if you set will execute code. There's various Outlook attacks you can do, but today we're looking at the last sub-technique, add-ins. So let's click on add-ins and read a little more specifically about add-ins. And add-ins is exactly what I just said, and custom-built extensions for Office to extend their functionality. They come in various forms, including DLLs that have been implemented in specific ways and then renamed to have either a WLL for Word or a XLL extension. There's VBA add-ins, and we'll be looking at those today for Excel and PowerPoint. There's also COM, VBE, and VSTO add-ins, but we don't have any automated tests for that, so we aren't looking at those today. If we scroll down a little bit, we see some procedural examples. There's the Bisonal malware or software that uses a WLL file for persistent code execution from Word. And also the Nacon group has also been seen using those DLL files renamed to WLL files and put in the Word startup folder for persistent code execution. Okay, so as we usually do in these recordings, we'll jump over to the Atomic Red Team library of scripted cyber attacks. It's a free and open source community developed project sponsored or hosted by Red Canary Co. Here I am in the Atomic Red Team project in the Atomics folder. The entire library of scripted cyber attacks is found in this Atomics folder, and if we look through this Atomics folder, we see a technique number right from MITRE ATT&CK. So here we want to look at technique T1137, sub-technique number 6. And in here we have some supporting files in the bin or binary directory, and the source directory has reference files with human readable files in there to support our tests. And then we have 2 versions of the technique file, the markdown version, MD, and the YAML version. The YAML version is the true source, official source of the scripted cyber attacks. It's very machine readable. It's not too fun to look at as a human, so this project also provides a markdown version, which is great for viewing it on the web. So let's take a look at the markdown version. Here in the markdown version, we see information copied right in from MITRE ATT&CK here at the top explaining this technique. And we see that we have 5 tests. All 5 of these are new. 4 of them were submitted to Atomic Red Team this week by myself, and the first one I updated this week. It was there previously just to make it work for both 32 and 64-bit and just work a little smoother. For these atomic tests, we have 2 attack emulations or atomic tests that use Excel's XLL format, one for Word's add-in format, and then we also do a VBA style add-in, XLAM for Excel and PPAM for PowerPoint. Let's start with looking. We're going to work from the bottom up today, so we'll look at the add-in file for PowerPoint. And this says it creates a VBA add-in file that runs automatically when PowerPoint is started. The sample file just launches Notepad. So to install this add-in, this Atomic is just going to copy our PPAM file that comes with Atomic Red Team in our bin folder, and it's going to copy it over to our app data folder in Microsoft add-ins and then notepad.ppam. And then it's going to create a registry key for Microsoft Office that says we have a PowerPoint add-in called Notepad, so that matches the file name here of our PPAM. So with that registry key added and this add-in file in our add-ins directory, every time we start PowerShell, Notepad is going to run. So for this attack emulation, we've chosen to just run Notepad to prove that we get code execution in an easy, visible way. But of course, in attack, that would be something more stealthy running in the background and would be the malware usually used to create a command and control connection to the attacker's server to give them control of this victim computer. We also have some cleanup commands that remove that Notepad PPAM file and also erase the registry key. So let's go over to PowerShell. I have Atomic Red Team library installed and also the execution framework that gives us this command, invoke atomic test. And then we just feed it the technique number 1137006, and then to start we could have it list the names of the tests that apply to our Windows operating system that we're on, and all 5 of them apply to Windows, so they're listed here, and this is just the same thing we saw in that markdown file, the list of tests. So we're going to start with test number 5, the PPAM file. So we can go back here and tack on a -5. Say we want to run test number 5, and before we run it we'll show the full details, so we'll take off the brief and we see the full details. It's kind of long, but it's not too overwhelming. If we look here, we have the commands that we'll run that we just looked at in the markdown file. This is an exact copy of what we have up above. Normally, if there were input arguments, those would show up above in red and then be filled in down here with their default values. But in this case, it's just a repeat of the commands from above. Here's our cleanup commands to erase the registry key, shut down PowerPoint and Notepad, and also remove the PPAM file. Then this last section is just dependencies. We can run the -check prereqs to check if we meet the prereqs. So it's going to do a couple things here. First is going to make sure Microsoft Excel is installed. And second, it's going to make sure that PPAM file is in our atomics folder so we can copy it. So if we were doing this like remote execution against another machine, it would check that that file is there, which it wouldn't be at first. And then you could say get prereqs and have it download that PPAM file. So we'll check the prereqs to make sure we're good. Everything looks good. Let's go ahead and run it. And remember, this is going to create that PowerPoint add-ins registry key that says run the Notepad PPAM every time PowerPoint starts. Then it's going to copy the PPAM file from Atomic Red Team into the App Data Microsoft Addins folder, and then it will start PowerPoint so that we can see that when PowerPoint starts, Notepad also starts our persistent code execution. There we go. We just started PowerPoint and it caused Notepad to start. So Notepad is a child process of PowerPoint, something we could look for in our detection. Not necessarily Notepad, that wouldn't likely be the thing that the attacker's executing, but child processes started from PowerPoint at startup. We'll close down Notepad and PowerPoint. The nice thing about these atomic tests is they often include the source code, which helps you understand how this PPAM file was created and also allows you to modify it. For example, if you wanted to execute something other than Notepad. But the PPAM files, the add-in files for PowerPoint, are a little tricky because if we open them up in PowerPoint and try to debug them, we're not able to. It won't show us what's the code that's part of that PPAM. So I'm going to right click on the toolbar here and customize the ribbon, and I'm going to turn on the developer toolbar where we would expect to be able to see the code associated with our add-in file. And I go to developer, and now I say view code, and this is where I'm hoping that I will see that PPAM file that's automatically starting, but I don't see it. And if I also go to PowerPoint add-ins, it is listed here. I can turn it off and on, but again, it won't show me that code, and I'm interested to see what that code looked like when that PPAM was created. So in order to do that, you actually have to add a registry key, and we want to have PowerPoint turned off when we do this, otherwise it will reset the registry key to 0 and when we close PowerPoint, and we need it to be set to 1. Here we need to go into the HKey current user, software, Microsoft Office, whatever version. You might not be on version 16. That's not really version 16 because I'm on Office 2021 or something. But anyways, whatever your version of install number here is, might be like 12 or 15 or 16. And then PowerPoint and options. Inside this folder, we need to right click and create a new registry key, which is a D word, 32-bit value, and it needs to be called debug add-ins. And then we need to set it to 1, and this will allow us to see that code from within PowerPoint. Now that we have that set, we can start PowerPoint. Of course, we see Notepad pop up again. Let's go back to developer and click on view code. And now we have this VBA project notepad. That's our PPAM. We see the module for this is right here, just a small VBA module that says run as soon as PowerPoint's open, and then it runs notepad. So you actually can't change this and save over the existing PPA. So if you wanted to make changes, you'd have to copy this into a new file and then make your changes and then save it as a new PPAM. But that should give you enough information that you could go in and create your own PPAM and modify this and play with variations. Let's go ahead and run the cleanup command. It's going to remove that registry key, delete the PPAM, and stop Notepad if it's running in PowerPoint. Now if we start up PowerPoint, we're back to not having Notepad pop up every time. Now let's look at test number 4. We'll show the details of that test. There's some dependencies like we had on the other one, but all this test does is copy an Excel VBA add-in. So I think the code's actually exactly the same as the PowerPoint add-in, but it just gets saved in Excel as a XLAM, a macro-enabled add-in file, VBA add-in, and that's gonna just copy it to our app data directory, Microsoft Excel start. So by putting it in Excel start, it automatically will run when Excel runs. So this is different than PowerPoint. PowerPoint, we had to copy our PPAM into the add-ins folder, and we had to create a registry key. For this, we just need to put the XLAM file in the Excel start folder. And then it starts Excel for us. So let's go ahead and run test number 4. Starting Excel, and we expect Notepad. There's Notepad. We close down Excel and start it again. We see it's persistent. The debugging of this is much easier. We don't need this registry key. We could delete it. We don't need debug add-in set to 1 here. We could just go in. We need to right click and customize the ribbon, turn our developer toolbar on. And then we could go to view code, and we just automatically see it here. So much easier to get to than it was in PowerPoint. And we can make changes in here. Okay, we'll run the cleanup, and all that's gonna do is erase that XLAM file from the Excel start folder and stop Notepad and Excel. Let's look at test number 3. This is the WLL test. The WLL examples and the XLL are actually DLLs, just renamed with a different extension. But they're DLLs written in a specific way to work automatically with Office. So for this WLL test, here are the attack commands. It's just, it does all this stuff at the beginning just to find out which version of Office we're on, Office 64 or 32. So it knows whether to copy the 64-bit WLL or the 32-bit WLL. So it copies that into the Word startup folder. So very similar to that last XLAM test. And then it just starts Word. So, I mean, it's more lines than the last one, but essentially the same thing. It's copying either the 64-bit or 32-bit DLL into the Word startup folder, and then it starts Word. And actually, in my testing and what I read online, it isn't working with Microsoft Office 365. So when you install Office as part of the Office 365 suite or subscription. But I did test it with Office 2016, just standard enterprise install or professional install, and this did work. You run the test, copy this WLL file in, and when Word starts, Notepad pops. So we won't demo that today since it doesn't work on my demo system here. Next, let's look at test number 2. Okay, the attack commands here, again, trying to figure out if we're on 64 or 32-bit. And then we copy the XLL file to Microsoft Addins. So this is the same place that we put the PPAM for PowerPoint. So for the XLL, we not only need to put the file in the Addins folder, again, like we did with PowerPoint, we need a registry key. So we have this Microsoft Office, then we have the version number, in my case it's 16.0. And we need an Excel options, and we need to set that to a key of open and a value of /r notepad.xll. And that's what'll make it auto run from the add-ins directory. And then we go ahead and start Excel, and we see Notepad run. So we can run this one. This works in Microsoft 365 Office. And there we have Notepad running again, our emulated malicious code execution. Now for this, if we wanted to tweak what it does instead of running Notepad, we wouldn't go into the developer toolbar and try to look at the code, the VBA code, because there isn't VBA code. There's just the DLL that's been renamed to XLL. So again, the nice thing about the Atomic Red Team project is that it comes with the source code for these DLLs. So if we go into our C Atomic Red Team Atomics folder, our default Atomic Red Team installation folder, Technique T1137006, and into the source directory, we have 2 projects, Excel XLL and Word WLL. In here, we have the entire Visual Studio, not Visual Studio Code, but actual Visual Studio. There's a free community edition you can use. We have the whole full solution file, which makes it really easy to open this up in Visual Studio, make changes, and then recompile without any issues. So I already have that open here, the Excel XLL solution. And here it is over here. There's a lot of stuff here, but the only thing that actually has been changed other than a default DLL core or skeleton is this DLL main.cpp, C++, and here we have the DLL code. So it takes some special functions here and linker options, but here's what actually executes Notepad. So as a proof of concept that we can tweak this a little bit, let's go ahead and change this to calc.exe. And we can go up here and say build the solution. and it says successfully built the solution, and it put it in this folder, Excel xll.dll. So let's copy that, take it into our file explorer. We want to grab a copy of this DLL, and we'll shut down Excel while we're doing this. Now we're going to go over to our app data roaming Microsoft directory and our add-ins folder. This was the Notepad XLL that got copied here when we ran the atomic test. We're going to delete this and paste in our new calc DLL. But we're going to rename it. We have to make it have a XLL extension. And also, since our registry key is still pointing to notepad.xll, we'll still call it notepad.xll, even though it's going to launch calc. Okay, now we go back. Actually, no, we just run Excel, and now we expect calculator to open up. And there's the calculator. Something different executing, shows us how we can modify that DLL code to run whatever we would like. Let's clean this up to get rid of that registry key and erase the XLL file. And then we'll look at the last test, test number 1. Okay, the commands to emulate this attack, again, very similar. We just need to know whether we're 64 or 32-bit Office. Then we copy our 64-bit well, actually, this is a little different. We're not copying anywhere. So this test, instead of actually getting persistence, so it doesn't totally fit here in the persistence category, but it does take an XLL file and it registers it using a function of a COM object. So here, Excel app equals a new Excel COM object. So Excel is going to get created and running in the background as a background process. We can't see Excel, but we've got this kind of handle to an Excel application that can do anything Excel can do. And then we ask it to register an XLL, and then we give it the path to the XLL, either 32-bit here or 64-bit here. So it's going to cause this DLL to execute its code by calling register XLL, but it doesn't actually copy the file into any folder where it's going to automatically run. So we'll get that same behavior of Excel launching a child process, in this case Notepad, but it won't be persistent. So here it's starting up that COM object. We've got Excel starting up in the background, although we don't see it, and Notepad popped up over here. It didn't come up over our screen. Let's close it down and just make sure that really came from us running this test. Let's watch for Notepad down here. Yep, so Notepad came up because we registered that. So that's another thing we could watch for in our detections. If you want to know more about Atomic Red Team, you can go to the GitHub project, Atomic Red Canary Co. Atomic Red Team, and go to the wiki. There's a vast amount of information there about the library itself and also the execution framework that we use to invoke atomic tests. You can also check out my online training called Attack Emulation Tools, Atomic Red Team, Caldera, and more from Antisyphon Training. We'll see you next time on the next Atomic Spotlight.